Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azim Anwar and my teammates is New Sabrina Bitin Nuruddin and Sheikh Najwa Bitin Hussein. So for today, we will like to discuss about a biophysical perspective on enzyme catalysis. For our table of content, we have 40 points we will discuss in this slide.
So for this topic is a biophysical perspective enzyme catalyst, and the others is Parcher K. Arger, and the years is 12 February 2019.
Next is abstract or synopsis. Enzymes are known to accelerate reaction by more than 10 power of 70 for understanding the detail of mechanism of enzyme catalysis of the factor that enable enzyme to achieve the remarkable catalytic efficiency has been sought for the more than a century. A wealth of information about enzyme has been obtained through experimental and computational investigation, particularly revealing that the importance of enzyme structure in catalysis. Enzyme residue that make direct contact with the substrate have been shown to have critical roles in holding the reaction participant in phase. Position and mutation of this residue are known to alter the speed or outcome of the catalyzed reaction. It is widely discussed that the shape of active site are complementary to the transition state of the catalyzed reaction, and the electrostatic environment of active site has been shown to be different from in the bulk solvent.
Just problem estimate of problem. Increasing evidence shows that enzymes are not rigid structures, but they are constantly undergoing a wide range of internal motions and conformational fluctuation.
Objective of study: to discuss the emerging biophysical model for enzyme catalysts that provide detailed understanding of the interconnection between internal protein motion, conformation substrates, enzyme machines, and catalyst efficiency of enzymes.
Limitation of study: population with mixed property, identify the conformational substate with homogeneous population, energy barrier.
Next, research questions and issues. Direct role of enzyme motion in accelerating the rate limiting step, which determines the overall efficiency of enzyme catalysis.
For the significance of the study, in this journal describe a perspective about how enzymes work based on studies performed. This perspective is not meant to claim that to completely understand all aspects of enzyme catalysis, but it is also note that investigation from many other research groups also continue to provide new and vital insight into enzyme function as well. Moreover, various enzyme structure elements and electrostatic environments enabled by the optimal positioning of the active site and distal residues play critical roles during enzyme catalyzed reaction, and no biophysical model would be complete without inclusion of their significant contribution to enzyme machines.
Conceptually framework: identify and modulate the conformation fluctuation excite the functional relevant conformation through addition of extra kinetic energy. Design the strategy enzyme and engineering of hypercatalytic enzyme. Develop a strategy that allows selective modulation of the correct conformation that promote the reaction. Provide an external stimulus such as the exposure to light. Attach link contain isobenzene of peptide on peptide and protein to change the conformation at fast time scale enable.
For organizations of digital review, this review describes a perspective about how enzymes work based on studies performed. Therefore, there were 3 literature reviews was shown.
For research methodology, an integrated view of protein structure, dynamic, and function is emerging, whereas proteins are considered as dynamically active assemblies, and internal motion are closely linked to functions such as enzyme catalysis. Detailed studies suggest that this network, extending from surface regions to active site, is a conserved part of enzyme structure and has a role in promoting catalysis.
For data collection procedures and data analysis procedures, for instance, the research was taken about 1 year to compare and compile all the data needed. Also, this work was supported in part by a multi-PI grant from NIH to PKA. The author would like to thank Nicholas Sturgeon, Elizabeth Howell, Kasbu Bhavna, and Chitra Narayanan for their interesting discussions.
Okay, next is summary of major finding. Okay, the first author is Richard J.P. Okay, the objective of major finding is to understand how enzyme work again and progress of origin of the catalytic rate enhancement of enzyme. Okay, the finding: enzyme that catalyze polar reactions such as carbonyl group addition, carbon are faced with the problem of facilitating the formation of highly unstable tetrahedral that does ignolate and respectively. Okay, the second author is from Mayer MP, Dr. Tom Key and Clement JP. Okay, the objective is to examine enzyme structure and dynamic effect hydrogen tunneling. Okay, the finding is this study examine the impact of series of rotation at position 553 on the kinetic and structural property of soybean. Okay, the last author is Agarwal PK. Okay, the objective is to define and quantifying the role of dynamic in enzyme catalysis. Okay, the finding is enzyme control chemical reaction that are key to life processes and allow them to take place on the time scale needed for synchronization between the relevant reaction cycle. Organization of report. The organization of the report is systematic and easy to understand. In this report, it helped me and my teammate to understand an emerging biophysical model, enzyme catalysis, that provide detailed understanding of the interconnection between internal protein motion, conformation substrate enzyme mechanism, and catalytic efficiency of enzyme.
So that's all from our team. Thank you for listening and watching.